because now that you know these two different things, we can move ahead and look at the next subchapter, which is about hybrid inverters. And I want to jump right to the whiteboard and use the same kind of setup that I used before. So we have the 4 pillars, right? We have the solar, the grid, the loads, and the batteries. Now, you know what all these components are. The string inverter takes DC, turns it into AC. The PV charge controller takes DC and turns into DC and charges the batteries. The battery charger takes AC, turns into DC, so that's a converter, right? And then the inverter takes DC and turns into AC. Now, what if we take all these 4 components and all the functionalities of the components and put them into one box? Then we get the hybrid inverter. That's what a hybrid inverter is. A hybrid inverter houses all these 4 components and houses them in one single box. It's not so much the components as in the functionality. So a hybrid inverter can do everything that all these other components can do individually. Now let's wire the system together and see how it could operate, how it could function in your setup. So we start by connecting the solar power from the panels into the hybrid inverter, because the hybrid inverter houses the solar charge controller or the string inverter or the grid inverter. And then let's connect the hybrid inverter to your batteries. And the hybrid inverter houses both the charger that can charge the batteries and the inverter that takes the power from the batteries and sends it towards the AC consumers, and connects the AC output from the hybrid inverter to the loads. So once you've set it up in this way, let's see how it could perform in a typical situation whereby there is no sun power. There's no solar power available, but there is a grid. So the grid would be feeding power towards the hybrid inverter. The hybrid inverter would make sure that the batteries are being charged, or that they are under like a trickle charge, so the batteries stay full. And then the hybrid inverter also feeds the power towards your load so that you can use whatever power you need at that moment. Alright, let him shut up for a second. I just want to explain to you that the content of this video is copied from the complete course of energy systems. If this information is enough for you, great. If you want to learn more and if you want to get access to the complete course, then check the information in the description below. Alright, you go ahead again. Another example would be if there would be no grid available, there's a power outage, or you just choose to not use the grid even though the grid is there, and it would be during the night, so there's no solar power available. Well, then the hybrid inverter can just take the power from your battery bank, takes the DC power, converts it into AC, so it's just a simple inverter that powers up all the loads in your house. And then the last example of another situation that could occur is if you're not at home and you've configured the system in such a way that it will take all the solar power available and, if applicable, power from your batteries and feeds it all back to the grid so you can sell it to the grid. So that's another situation that could occur. What I'm trying to explain to you, what I'm trying to show to you is that the hybrid inverter has got all these functionalities of all the separate components housed in one box, in one unit, and it is really the hub in between all your different loads and power sources, right? And it has the intelligence, the brains, that you can tell it what it should do in a specific situation. Now let's go online and let's look at an example of a hybrid inverter. So let's look at the company atespower.com. I'm not affiliated, and I'm hoping that I'm pronouncing the name correctly. So the purpose of this exercise is to show you that one hybrid inverter houses all the different functionalities that we just discussed. So the 4 different connections between the hybrid inverters and the components around it. So let's go to products. And then, there you go, hybrid inverter. Let's select the first one. ATES HPS 5000, 5 to 10 kilowatt single phase, all in one. So here you can already see that it's a hybrid inverter. 4 connections connected to the battery, to the load, which is you, the consumer of the power, the grid, and the solar panels, the solar connection, right? So let's scroll down and let's look at those 4 different functionalities that are housed into this one unit. So the first one is the AC connection to the grid, so the connection between the grid and the hybrid inverter. The second one is the AC connection between the hybrid inverter and you, the consumer, so they call that off-grid. And then here you can see 2 in 1. So it's the DC connection between the hybrid inverter and the battery pack, as well as the connection between the hybrid inverter and the solar array. So there you can see the 4 different connections, 4 different functionalities housed in one unit. And let's look a little bit more specific at the values that we can find here. So if we look at the first model, so the HPS 5000 TLS, we can see this has got a rated power output of 5 kilowatts. And the total harmonic distortion by means of the current, so the THDI, is less than 3%. And it's a 230 volt model. And here in the second section you can see the values for when you're running off grid, so that's the connection between the hybrid inverter and you as the consumer of the power. And you can see that the rated power is equal to that for the grid connected. It's 230 volt of course as well. And the total harmonic distortion is less than 2%, which is pretty good. And you can see here that they indicate the peak power by means of the overload capability in percentages of the rated power. So you can draw 110% for 10 minutes or 120% for 1 minute, which makes a lot of sense. You can normally draw more than a nominal rated power from an inverter for a certain amount of time. And then here in the third section we can find the values for the connection between the hybrid inverter and the solar panels and the hybrid inverter and the batteries, right? So we have here the value on the maximum open circuit voltage from the panels towards the hybrid inverter at 600 volts, which is really good. So you can build really long strings, so very high voltages on your solar arrays. You can also see that it's got 2 separate MPPT trackers, which is really nice. So you can actually make 2 separate groups of panels and all connect them both to their own MPPT tracker. So you can visualize this by imagining that this hybrid inverter houses 2 separate string inverters, right? So you can make 1 string of solar panels with a maximum open circuit voltage of 600 volts connected to 1 MPPT, and then another set of panels, maximum open circuit voltage 600 volts, and connected to the second MPPT, which is a really nice option to have. Then you can see here a little bit lower, you can see the values for the connection between the hybrid inverter and the battery bank. So what is quite important to notice that here it says that the minimum battery voltage should be 85 volts. So it is a relatively high voltage battery bank, which is no problem, but it's just important to be aware of. And it says here that the maximum charge current is 25 amps. So they have 2 values. They say either way it's a maximum of 5 kilowatts or a maximum of 25 amps, which then suggests that it's more advantageous for you if you use a battery bank with a relatively high voltage. And then if we scroll down, we see a couple of more of the values that we already discussed before. We're going to the design of inverters. So you can see here that the cooling is forced air. And another thing that we discussed before, right, the display, the user interface, so it's a touchscreen display. So that's just an example of a hybrid inverter which you could get on the market.